Here's a question a lot of algebra students have. Adding 1 to a function shifts the function up, but when you add 1 to x, it shifts the function left. Why? So let's start with the easy part, and let's just use an easy function to illustrate this. Let's take f of x equal to x squared. We all kind of know that its graph is this parabola shape, and this is the easy part. If you add 1 to the function, it shifts the graph up by 1, and that just makes intuitive sense because adding to the function gives it sort of like more y values, right? And up is the positive direction, so if you give more, then everything just kind of gets bumped up. I think we all kind of intuitively grasp that one. But here's the confusing part. If you add 1 to the x coordinate, which is to say, let's be now really clear, we're talking about making the y coordinate of our graph given by the function f of x plus 1. In this particular case, that means that we are taking x plus 1 all squared, and this seems to take the old graph and shift it to the left. Now that the left is the direction of smaller x's, so why is it that when adding 1 to x, you shift things towards smaller x's? Well, let's start by thinking about the relationship between the vertex here, which is what you get when x is equal to 0, and the vertex here, which is what you get when x is equal to -1. In this one, to get the x plus 1 part equal to 0, then you have to, right, like you subtract the 1 to the other side, getting you smaller, right? Over in the original function, you would simply set x to 0, but here, to get the stuff under the square equal to 0, in this situation, you have to subtract the 1 to the other side to get the appropriate input to x. Now, think about it like this. Suppose that you pick any point on the original function graph, right? So you've got an x and a y. They're somewhere on this graph because, we're saying that we're plotting y equal to f of x, right? So x and y are a point on this graph. Now, how are we going to relate that to what you have when you're talking about x plus 1 squared? Well, certainly I can introduce a plus 1, but then I have to subtract it back out. I know that often seems like kind of a weird move, and it is, but I think it'll lead to an explanation here. Now group the x and the -1 together. Here what we're saying is that what we need this thing to be, right? This x minus 1 is now in the place, right? Because the plus 1 is separated off. Then we're saying that our new value of x has to be equal to x minus 1 in the old function. So effectively what this says is that what we need here for this x is 1 smaller than what we needed to accomplish the same value in the old function. Another way to think about this that might be helpful and intuitive is to think, well, let's start from just any arbitrary function, we'll call it f of x, and now this time, rather than thinking about grabbing the graph and shifting it either up, down, left, or right, but instead think that what you're doing when you write x plus 1 is you're not shifting the x of the graph, you're shifting the x of the graph paper, basically, right? You're grabbing that x-axis and shifting it to the right by 1. And now think about what has happened to the graph if you are in the perspective of the new coordinate plane, this new shifted coordinate plane. Let's think about, just for an easy point, when in the old system you would set x equal to 0, you would get this point right here. Well, how do you now, in the new system, get that point right there? You have to plug in -1. You have to move to the left this time by 1 to get to that same old coordinate. So when you add 1, you're in fact shifting not the graph of the function, you're shifting the coordinate plane on which the graph is drawn. Now, I think a very reasonable question in response to that is, why are they different? Why is the rule for the y variable different than the rule for the x variable? If you have that question, let me know, and I'll make a separate video on that.